Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 8.6 entitled Exponential Growth Functions. And today we're going to talk about how you can use an exponential growth model to solve a word problem. And this model that we're going to use is laid out right here. Y equals c times 1 plus r to the t. And exponential growth, remember, is when a quantity increases by the same percent for each unit of time. So even in the graphs that we saw in the previous section of notes, when we had an exponential growth, it meant that the base was staying the same and the exponent was increasing by 1 when we were making our table of values. So you were increasing the same percent because it had the same base, and then each unit of time, which is 1 unit when you're making your table of values, and you could see how fast the graph increased or how fast it grew. So we're just going to put that into an equation now. And we're going to have some different parts to it. Instead of the little a out in front like we saw previously, we're going to have a c, but that's still your initial amount. So we're going to talk about all kinds of things. We'll talk about germs, or we'll talk about money, or we'll talk about animals. Okay, so this is your initial amount, your starting amount. Okay, the 1 is always going to stay a 1, and this is always going to be a plus for growth. The r is going to be your rate. Now, if they give it to you as a percent, you have to make sure that you write it as a decimal. And then t is going to be your time. So your growth factor is this 1 plus r. Okay? So the 1 plus r, that is your growth factor. So if you hear that in the rest of the notes or in homework or in quizzes or tests, that's what that means. Okay? Now there are a lot of things in the real world that increase exponentially or grow exponentially. Okay, rabbits and frogs and fish, bacteria, certain types of viruses, the population of people, interest payments. These are all good real-world examples of animals or other cases where you see exponential growth in the population. So we might see some of those examples here. We've got 4 examples that we're going to go through. And for example 1, they just want you to write the function. So we're not going to solve it or anything like that. We're just going to practice writing it. Okay, so we want to make sure that we know where everything goes in that generic equation that we had. And that was y equals c times 1 plus r to the t. So as we're reading through these scenarios here, we need to look for our initial amount and our rate and our time. So those are the 3 pieces of information that we need. Okay? So here you have, in part A, your salary of $35,000 increases 8% each year. Okay, so the 8% is pretty easy to identify as your rate. Now again, we're going to write it as a decimal, so we're going to have to change it from 8 to, you move your decimal back 2 places, 0.08 when we plug it into our equation. The 35,000, that's going to be your initial amount. That's where you're starting. And you can kind of figure that out because your salary is starting here and then it's increasing each year. So that year is going to be your time. But they don't really tell you for how many years. So when we write this equation, we'll have y equals 35,000 times 1 plus 0.08. And we're just going to leave t as a t for now because they don't tell us how many years you're getting this increase for. If they told you it increased 8% each year for 15 years, then we would put a 15 in for the time. But we don't know exactly how long this is going to go on for. But we can simplify this just a little bit more. We can add the 1 and the 0.08. So it'll look a little nicer if we write 35,000 times 1.08 to the t. That would be our function for this situation. Okay, for part B, we have an initial population of 30 rabbits, and they even use the word right here, initial. So that's our starting amount, that 30 rabbits, that's going to be our C, and it doubles each year for 6 years. Okay, now this doubling, this is important. So I don't see anything with like a percent for a rate, but I bet that doubles is going to be our rate. And they tell us that it's increasing each year for 6 years. So that's going to be my time then. This time they actually tell us the time, 6 years. Now, when something doubles, we have to figure out how we're going to write that. Okay? Now, the number that I normally have in here in my equation is 1 plus my rate, 1 plus r. So I'm starting with 1, and I want it to double. Okay? So to get 1 to double, I really am starting with my 30, and then I have 1 plus 1, because 1 plus 1 would be 2, and then it would be double of what it originally was. Okay? So I'm going to start out with my 30 rabbits, and then I'll have 2 for my rate, and then this time is going to go on for 6 years. So that would be my function or my equation for this scenario. So sometimes students have this make sense where it's 1 plus 1 because you're starting with the original amount and then you're doubling it, so you're adding the original amount again. Some students may have it make more sense when they finally see that 2 because they know that multiplying by 2 is when you double something. So anytime something's doubling, it has a base of 2. If it was tripling, it would have a base of 3. If it was quadrupling, it would have a base of 4. So they might try and put some of that vocabulary into your homework problems as well. Okay, now example 2, 3, and 4, these are going to be the same type of equation. They're all going to deal with money and interest. They're just going to be worded a little bit differently from one to the other. But it's the same equation we've been working with. C times 1 plus r to the t. And we're still going to find those 3 pieces of information and put them in, except now they want us to actually find a number, okay? Because it's going to say find the balance. So here you're depositing $2,500 in an account that pays 4% interest, compounded yearly. Now, we don't have to really worry about that too much right now, how often it's being compounded. That's just a fancy way for now for them to say that this is some type of an investment problem. There are other formulas that you can use where you adjust how often it's compounded, but we're not going to see that here, okay? But they do want us to find the balance after 15 years. So we've got some key pieces of information here. We've got our 2,500, that's our initial amount. We've got our 4%, which is going to be our rate. So that's my C, this is my R, and then I've got the 15, which is going to be my time. But remember, this rate is 4%, so I'm really going to turn it into 0.04 as a decimal. So now I'm going to substitute all this information in. 2,500, 1 plus 0.04 and then 15 is going to be t. Now we're going to simplify this a little bit before we use our calculators. I'm going to add the 1 and the 0.04, so I get 1.04. Now, when you're putting this into your calculator, you need to do just the power first. Sometimes students want to multiply the 2500 and the 1.04 and then raise it to the 15th power, okay? But if you multiply the 2500 and the 1.04, that changes the base, and we don't want to do that. We only want the 1.04 raised to the 15th power because it's the one that's in the parentheses here that the exponent's attached to. So do that part first, then you multiply by the 2500 afterwards. Okay? And then when you do that, you should get, now this is money, so we're going to round our answer to 2 decimal places. So you should get $4,502.36. Okay, now example 3, same type of problem. We're still dealing with money and how we invest it. It's just worded a little bit differently from how the previous one was worded. Okay? It says you deposit money into an account that pays 7.5% interest compounded yearly. So there again, they're telling you your rate. Find the balance after 5 years. That's your time. For an initial amount of $4,100. So in example 2, they gave us the amount up front. They said, you deposit this amount. Okay. Now they're not telling you the amount until the end. Big deal. We're still using the same equation. We still can find all the pieces of information that we need. It's just in a slightly different order. So we're going to start with our $4,100. I'm going to rewrite my rate as a percent. So that 0.75, or I'm sorry, 7.5, I have to move the decimal back 2 places. So it's really going to be 0.075. Sometimes students forget that 0 in there. And then it's for 5 years. So again, we're going to simplify this before we put it into our calculator. We're actually going to add those together. And then again, when you do this, make sure you do this the power first. Do the 1.075 to the 5th power, hit enter and get an answer, and then multiply by the 4,100. And you should get, again, this is money, so you're finding your balance after 5 years. So after 5 years, you should have $5,886.08. So if you needed to write that as a complete sentence, you could say, after 5 years, I will have $5,886.08 in my account. All right, one last one. Example 4. You're depositing $750, so there again, that's your initial amount, into an account that compounds interest yearly. Find the balance after 9 years, so there's your time, for an interest rate of 4.7%. So now instead of telling you the interest rate right away, now they're telling you the money right away and the interest at the end. Big deal. It's still the same 3 pieces of information. It's still the same equation that we're using. It's just rearranged a little bit. So as you read these problems, don't think that they're completely changing the problem. You're still finding those 3 key pieces of information. So again, we're going to have our $750 to start with. And here again, we have another decimal for our rate. We have 4.7%, so we're going to move that decimal 2 places. So again, don't forget that 0 there for the placeholder. And then our time is 9 years. And then simplify this just a little before you plug it into your calculator. And when you put this into your calculator, do the power first, get an answer, then multiply by the 750. And when you do that, your ending balance should be $1,133.92. Again, if you wanted to write that as a complete sentence, you would say, after 9 years, I will have $1,133.92 in my account. So no matter how the problems are worded in your homework, look for those three key pieces of information: the initial amount and your rate and your time. So no matter how it's worded, find those pieces of information, and then you'll be able to substitute and simplify and get your answer. So if you have any questions, come on in and see us before school. Make sure you show your work for these problems as well.